Hi everyone. I'm going to do a quick video on the 6-inch dial caliper and do a little measuring with that. So let's go over the anatomy of this guy first, right? So the thing that kind of sticks out right away, right, is the dial. It's kind of synonymous with dial caliper, I guess. Huh? Then you have the body of it. That's the whole structure itself. This portion that's moving by my thumb moving it back and forth, that's called the carriage. And then we have the jaws. Some call these blades, but that's depending on who's telling you. We also have these two appendages right up here that are kind of cool because that's for doing internal measurements. These would be used for external. And then there's a couple more ways to measure with this that I'll get into. So what a dial caliper does is it takes 1 inch and divides it into 1,000 equal increments. And if you look at the dial, we'll start there. We'll jump right into it here. If you look at the dial, right, it goes from 0 past 90 and then back to 0. Well, that's 100 equal spaces around the dial, which equals 100 thousandths of an inch. You can see down here on this scale where my thumb is. You can see as I went around the dial, I went from 0 and I went around the dial, and the carriage marks my spot at 1. Now, the reason they have that scale on there is so that you don't have to constantly count the number of revolutions around there and then add it to whatever. So that's a way of tracking how many times the needle's gone around the dial. So there's 100 thousandths of an inch. And then 2, 3, 4, right? You get the idea until we get all the way out here to the actual 1 inch. You can see that the 1 inch is kind of set apart from the other numbers, makes it identifiable. Right there, you can see that a little better. And I'll try to do a better job keeping in focus. So that's all fine and good, but what if I'm measuring something that isn't exactly 0.1 or 0.2 or 0.3 or point, and it's some fraction of that between the 1 and the 2 or the 3. So let's just say hypothetically I'm measuring something and it happens to be that big. Well, I've gone past the 3, so I know I've gone at least 300 thousandths, but I haven't made it to 4. So what I would do is it would be 0.3 plus whatever's on the dial, because that would be a fraction of that distance between the 3 and the 4. So if I read that, you read that clockwise, you come right around the dial, my measurement would be 0.3 plus the dial is 90, let's say 93. So the decimal would be 0.393. So that's how you would measure. All the way down the scale, that holds true also. For instance, let's just go to a random spot here. So you'll see that I had 1 inch back here. Well, then, of course, it's progressive, right? 2 inches, 3 inches. Well, I haven't gotten to 4, so there's one part of the clue. So I'm at 3.5, and then we add the dial to that. So it would be 3.537. So that's what the decimal equivalency of whatever that measurement was. And that distance is represented right here from that jaw to this jaw. And that holds true right out to the 6 inches right there. So you can really get accurate measurements with this. Way, way more accurate than you would do with just a scale. If I wanted to measure something, for instance, this bushing I have here on my desk, if I wanted to measure that, I really can't get that accurate as to how big that ID is, how big that OD is. And that may be important to me. So then what I would do is I would use my calipers to do the outside measurement and then the inside measurement. You can see how I did that. I took those fangs right there and put them inside, and that will give me whatever that diameter is. And this measurement happens to be 0.7 5, 6. So that's how accurate we can get with these. So let's see, what are some of the other ways I can measure with this? We've done this, right? That's the outside diameter of this particular bushing. We can also do the length of the bushing too. That might be important. We need to know exactly what that is. In this case, it would be 1 inch, 5, 7, 2. So that's kind of fun. Another way to measure with these that's kind of interesting is, you know, when we did the anatomy of this guy here, right, we have the blades or the jaws, and then we had the internal blades. And then we have the tail of the caliper, which is actually another point you can measure from the end of the tail to the body of the caliper. And that'll give you a dimension. If you were to use that, how you would use that is you would put like the tail on the surface and bring the body down on top of the opposite surface right there. And that would give you what they call the drop. That's the distance from here to here. And in this case, it would be 1 inch, 0.111. Wow, imagine that. And the fourth way of measuring with one of these is this surface right here. You can see that flat edge right there where my finger is, to this flat surface right here. And the way you would do that is this surface would sit on this point right there. Right, you can see that. And then this one comes down on top of that other surface. And that would give you whatever that drop is. It should match whatever is here. So, to give you an idea of accuracy, right? When I measure something, the distance between these jaws right here and these blades right here are jaws, and the tail, which is here to here, and then these two surfaces right here are all exactly the same. So this measurement that we've gotten from our scale and our dial is exactly the same distance from here to here, 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 and then from there to there. So that's pretty cool how these are made. Reasonably priced also for all that precision. That's pretty neat. And one last point, if you haven't already watched a video on rack and pinion, this gives you an idea of one use for a rack and pinion. If you look, see if I can focus in on this a little bit better. If you look right here, this isn't working out too well. That's a little better right there. My lighting's bad for me. But you'll see these teeth right here along this bar. That's called a rack. And inside of this dial, there's a gear that matches the pitch of this rack. And as you slide this, the pinion gear spins and tracks along the rack. So we're going from radial to linear motion just by pushing those open and close like that. And that's where you get your accuracy. So that's kind of a fun fact. So that's it on dial calipers. Hope that helps.